Good afternoon. My name is Zoltán Rácskai. I work at the Hungarian Academy of Sciences, Computer and Automation Research Institute. My presentation today will be about one of our recent developments. This is our virtual and augmented reality engine called ApertusVR. So this presentation that I will hold today is also an application that we have written in our programmers library, in this ApertusVR programmers library, which is actually a true full 3D mind mapping application. And it has a lot of features related to all the other mind mapping tools. So I hope you enjoy it. This is the first slide, which is actually our GitHub page. This is a browser inside the virtual reality space. And in this browser, we can see our GitHub repository. ApertusVR is absolutely free. It is an open source application, and it is MIT licensed, which means that you can use it as your own code. You just have to sign or to show that the original code is written by our research group. But just grab it, clone it, and use your own. And we really hope that you will see the potential in this sort of software system or programmer's library. It contains 8 million lines of codes, which means that you have total control over the whole process or all over the whole application that you write with the help of ApertusVR. So if we roll here down a bit, this is the general structure of ApertusVR. As we call it, it is a free, distributable, and scalable virtual reality engine. Why is this important? Scalability is important because most of the virtual reality engines that are used today have certain limitations. They are closed, they are closed frameworks, they are dependent, and they cannot handle the situation that if different types of hardwares want to be joined to those specific platforms. Most of the platform owners who are developing the VR engines or platforms, they also develop hardwares that are dependent on those platforms. Well, we just decided to go right opposite the flood, and we thought that it's okay, but somehow if you have to develop the content for the different frameworks or different platforms, it costs a lot of money, human resources, efforts. Actually, all of these are money. So you just waste your money. So we decided to separate the things. There's a core, Apertus core. It is written in C++. It is actually just responsible for the synchronization of the scene among the different hardware elements. And there are the different hardware and software elements that connect to this core as a plugin-based structure. It is very easy to write a plugin for the ApertusVR, and you can switch on and off these plugins dependent of your needs and dependent on the application that you would like to write. So these are the basic elements that we integrated into our software system or programmers library. This is, I think, absolutely clear. The hardware elements and this sort of ad hoc network is connected through internet, which means that there's a server-client relationship or client relationship, but it is not strictly a dedicated server that all the clients are connected to. So if something happens and the most capable hardware device just falls out due to something, I don't know, then according to the last synchronization used or achieved by the Apertus core, one of the former clients just take the role, the host role, and all the other hardware devices connect as previously or formerly guests. The synchronization of the scene is achieved, and actually everything is going just like before. Well, almost nothing happened. Like almost nothing happened. An absolutely typical application or scenario are, for example, particle simulations, particle simulations, which means that you have an APHC server, for example, this one here, rigid body simulation, thank you. So you have an APHC server which does the math, and you also have devices that you would like to show the simulation. Well, for doing the math, you don't need rendering, which means that you will need the Apertus core plus that plugin that does the math, that uses that hardware element, in this case, the HPC server, to do what is needed. Then, if the rigid body simulation is ready and everything is done, then you can use other devices like your desktop or laptop, or as in the car industry, cave systems, display systems, or AR glasses if you are on the field, if you have to do something and you have to coordinate the physical world and the virtual world. HMDs, if you are just in a park but would like to see the end result of the simulation. With all those devices, you can connect to the host and see the result. But these devices, most probably a phone cannot run a rigid body simulation. So, but all these devices are using just one part beside the Apertus core, which is rendering. Of course, a 360 camera is not a display device, but there are certain situations where you can use several different 360 cameras that you can connect into one scene, and depending on the application. For example, in the near future, most probably, we will have a project that is all related to 360 cameras and immersive media services. So you can use these devices, and they are all synchronized through the Apertus core. That is absolutely platform independent. So here's a little about part. Or ApertusVR offers a brand new no-vendor lock-in approach for virtual and augmented reality on different operating systems and on different virtual and augmented reality hardwares. This is what we discussed just before. This higher abstraction level enables that the business logic has to be implemented once, and then it works on any platform. Moreover, these different virtual and augmented reality hardware can be shared a same virtual reality scene at the same time. Different hardware types, different platforms, different hardware providers. But you can collect all those things and all those hardwares dependent on your needs, looking for advantages of these hardware elements, but exclude the disadvantages. So using a Samsung HMD, yes, HMD, and other controllers that are more suitable for your needs than the Oculus controllers. And previously you couldn't do that. With the help of ApertusVR, now you can. And this is what we think is a really, really important thing. Because developing a new hardware for a system that is dependent costs a lot. But if there are something that is really, really in your hand and you can feel it and use it as you wish, but you cannot use it because of the hardware dependencies or platform dependencies, is really, really upsetting. We experience it, we know it. ApertusVR engine only contains libraries in order to easily integrate the virtual and augmented reality technologies into an already existing product. By the help of the factory plugins and samples, ApertusVR could boost up the creation of a minimum viable product from scratch. As we are not a platform, but we are more a programmer's library. You can append these VR and AR technologies to your already existing and really, really good working developments. You don't have to, and this is what we were previously talking about, you don't have to create the content for all the platforms or all the hardware platforms or OS platforms that are present in your production place or production workflow. We use CMake and we have SDKs, and as we evolve, we really, really hope that most of the, or yes? We hope that most of the platforms or the recent platforms or the most vital platforms will be covered as soon as possible. Yes, you can submit issues and feature requests. We're absolutely open to it. And of course, we'll integrate everything that makes this programmer's library better and better. So this is our website. This is, I think, absolutely clear. And this is our team. This is our head software engineer or software architect, Péter Kovács. He has more than 10 years of experience in software development and at least 8 years or 9 years related to VR, virtual reality. This is Ákos Hámori, software engineer. He worked for an Austrian company in hardware development or hardware, software development close to hardware. Also had the pleasure to work for Google. This is myself, web developer, communication PR. I try to speak understandable. In most of the cases it works. And this is our newcomer colleague. He's doing his thesis at our team, and he's doing all the image processing related to one of our use cases or one of our two projects. These are our partners. We developed a really good relationship to Epson as we try to use the most accessible and most professional AR glasses that are available on a daily basis. And of course, we started our relationship to develop with Samsung. This is one of our recent projects. We will talk about it a bit later. Some use cases and also the contact information if you would like to write some nice emails to us or for us. And yes, that was it. So next slide. Ooh, AR. I mentioned Epson. Epson is one of those companies who try to develop a response, an industrial response for the market related to AR glasses. They started to produce an industrial-based, or for the one of the AR glasses for the industry. It is durable. It is meant to use with the hard cap or hard hat that you use in the industry, and also especially for industrial applications. One of the companies in Hungary. One of the companies in Hungary who is working in the plastic producing or plastic fabrication part of the industry, Karsai Holding. They are one of the most professional plastic factory in Hungary. We developed them a user's manual based on AR. They have a product called Moto Hot Wear, which is actually a liquid-based heating system for forklifters and for motorcycles, and the assembling and installment of this heating system is quite sort of complicated. So we started a collaboration to build up a user's manual that uses actually an HTML-based UI and also the AR kit, not AR kit, AR toolkit that is connected. So we use, in this case, Apertus Core. We use an Android plugin that so it can build on Android, and a rendering plugin, Ogre, and you can use actually tablets. You can watch and use the user's manual on tablets and on Android phones, and of course on iOS phones, because it is also uploaded on a dedicated server, so on a web server, and so you can use actually all of the devices to watch the video that contains the AR rendered assembly steps. No, not this one. This one. This is endocapsula. They are. What? I don't have time. My time is up. Okay, then I try to be a bit faster. So this is a private clinic, and there are two separate things that are related, that are put together in this project. One part is an AI and image processing part. They use colonoscopy and colonoscopy videos and still images to collect about the polyps, and based on the image processing, they the AI can decide, a neural network can decide, or helps to decide the young doctor, if it's an adenoma or is it hyperplasia. So actually, it can boost up the accuracy of the young doctors who don't have the enough experience for the diagnosis. The other part is a shareable or distributed scene where all the other specialists can interact and do a consilium or a consultation with each other, and they connect. They can connect via internet from all over the world, so they don't have to be in one place. They can annotate the examinations. They can draw on the pictures, and of course they can interact via text chat and voice chat. This is another use case. Yes, T-Mobile or T-Systems. The general demand was that they have a lot of 3D data about the facilities and about the pipes actually, and electricity and all the building information. So yes, thank you. About the building information, and they wanted to do a development that ensures that you can use your devices, iOS devices and Android devices, to actually look after where the pipes are in AR and also in virtual reality, so in VR. Here we use the Apertus Core and also the two, so the main systems, so the build actually for iOS and Android, and the rendering plugin. Nothing special. So Pigeon and Clay. Pigeon and Clay is a company that produces parts for cars, and they are also very, very strict and very serious suppliers of American car factories. There are two main things that we have to deliver them. One is to One is warehouse picking, then three. Warehouse picking, so how to fasten up or how to make it faster to pick the parts from the warehouse or the necessary things that you have to use for the production. The other one is predictive maintenance, which means that they install sensors on the production units or the production places, so milling machines and industrial robots that put one thing to the other, or welding robots. So they collect sensory data, and with the help of this sensory data, they want to predict when to do the maintenance on the specific units. Of course, here we use the Apertus score. Dependent on the sensor, we have to develop a sensor plugin that collects and the data actually, and then there are two very important things. One is the collaborative scene, where actually the specialist can explain the user or to the worker. Thank you. To the worker, how to do actually that maintenance if the specialist is not on the place. Shop floor. Yes, thank you. Shop floor. And here's one of the visions that we have. So the both of us, President Clay and us, to do to predict the maintenance like this. And the other one is to visual verification. So you can use actually that shared 3D space to visually verify the product, if it's good, if it's not, if it has the desired properties or not, and so on. And yes, this is also related to Priggen and Clay somehow. This is the Quality Vision International and Smart Profile company. They use this GD&T tolerances. So they are. So this project is about GD&T tolerances. This is metrology, actually, and they measured the CAD model. They compared the CAD model to the physical first prototype, and they tried to about this comparison, or out of this comparison, you can see the tolerances if it's inside the desired tolerance or not. Well, here we have to visualize or do the visualization of the CAD models and the rescanned physical model or rescanned physical product. And with the comparison, visual comparison, you can see if the two things are aligning or if the physical product is inside the tolerances. Woo. Here. Symbiotic. This was an in-house project. One of the other research groups or research laboratories inside our institute participated or participates in this project. It is actually about how we can remote control how we can interact with industrial robots, and how this interaction can be put into a virtual space, or how we can use virtual space or virtual reality technologies to put together with the physical world, and the physical production line. So it is not only simulation, because in simulations you just have the virtual model, do something, then you get the result of the simulation, and you try to fine-tune the physical system. In this case, we thought, well, let's put the two things together and try to remote control from the simulation. Let's remote control the physical production line right out of the simulation. And the colleagues in this research laboratory have put together an experimental production environment with gesture control, how to stop the robot, and so on. This is one of the figures that is showing this approach. Because with voice command, well, in a factory it can be loud. Voice command is not necessarily the best solution for this problem, but gesture control has a quite good result according to their research program. Well, our part was to do the virtualization of this physically existing production environment, and to build up the remote control and the collaborative workspace part. Well, we did this. We virtualized exactly. So we did a virtualization of this physical production environment. It is absolutely the same. So the two things are absolutely the same. And we collect via sensors the data from the physical production environment, and we can see these movements or this. So what is happening in the physical world, we can see in our virtualization. Our virtualization, on the other hand, can send data to the physical part, and if something happens not according to that, what we want in the physical one, so the colleagues can alter all the things that they need via our virtual part, and the physical, so the industrial robots. So the robots are absolutely responsive. So they do what we want in the virtual space. And we used actually ApertusVR. We have written an interface for linkage designer also, because the kinematic chains for these industrial robots were calculated with Wolfram Mathematica and put together with linkage designer, which is the product of one of our colleagues, Gábor Erdős, and he was that colleague who conducted this experiments or research program for, can I say it loudly? for whom Gabor did this research program? For Hitachi. But yes, this is our yearly annual report in Hungarian. So that was actually everything that is ApertusVR and what we achieved till today. It is in our annual report. And I hope you liked this presentation. I was kind of nervous, but I hope it was enjoyable, or at least understandable. And I look forward for your questions a bit later. Thank you very much, and have a nice day.